What if you could start fresh and leave Earth behind forever? Imagine stepping onto a massive space station, floating peacefully above the planet, equipped with artificial gravity, clean air, endless resources, and with access to both disease and cancer-curing medical technology. Would you be allowed to go? Or would you be cast aside as a casualty of the great effort to build such an exclusive destination? That's exactly what Elysium envisioned. A highly advanced space station where the elite live in luxury while the rest of humanity struggles below on a decaying Earth. But how close are we to making that a reality? Could we actually build a livable, sustainable space colony? Or is the dream of space habitation destined to remain science fiction? Today we're going to explore exactly what it would take for humans to survive long-term in space. The technology, the challenges, and how far we are from making this a reality. We'll also break down the science, the obstacles, and the effects on our society if humans were to achieve such a feat. Let's start with the big question. Why would we even want to live in space? Earth has been our home for over 4.5 billion years, and it's been incredibly good to us. But as humanity advances technologically, our population grows and our environmental footprint increases. We're starting to push the planet to its limits. Climate change, resource depletion, pollution, and geopolitical instability are all signs that Earth might not be able to sustain human civilization at its current pace for much longer. And that's where the concept of space habitation comes in. Movies like Elysium portray a future where Earth has become overpopulated, polluted, and economically stratified. In the film, the wealthy elite live on a luxurious, rotating space station above Earth, while the rest of humanity struggles in overcrowded slums on the surface. The movie's central conflict revolves around this imbalance. The idea that salvation and opportunity are only available to those rich enough to escape Earth's problems. But beneath the dystopian narrative, Elysium reflects a deeper truth. Space offers an escape from Earth's limitations. On Earth, our resources are finite, but in space we could tap into the near-limitless supply of minerals and metals from asteroids. We're also vulnerable to climate change, natural disasters, and extinction-level events. But a self-sustaining colony in space would create a backup for humanity, ensuring our survival even if Earth becomes uninhabitable. We also have political and economic instability due to a lack of resources which creates conflict. But space could offer a fresh start, where new political systems and social contracts could be designed from scratch. Right now, human civilization exists in a precarious position. A single asteroid impact could cause a mass extinction event, much like the one that wiped out the dinosaurs 66 million years ago. Supervolcano eruptions, nuclear war, or even runaway climate change could make large portions of the planet uninhabitable within decades. Stephen Hawking famously warned that humanity would need to colonize other planets within 1,000 years to avoid extinction, and later revised that prediction to just 100 years due to the accelerating pace of environmental destruction and technological threats. Space colonization offers a literal safety net, a second home for humanity. If Earth faces a catastrophic event, a self-sustaining colony on the Moon, Mars, or an orbital station could ensure that human civilization and the accumulated knowledge and culture of our species survives. Living in space isn't just about finding the right location. It's about surviving the harshest environment imaginable. What makes living in space so challenging? For starters, gravity, or lack of it. The human body evolved under Earth's gravity. In microgravity environments like the ISS, astronauts lose bone density and muscle mass at alarming rates. NASA has found that astronauts lose about 1% of their bone mass per month in space. Over time, this leads to osteoporosis-like conditions. Artificial gravity, like the spinning wheel design in Elysium, is a possible solution, but the engineering is complex. A rotating station would need to spin at just the right speed and size to simulate Earth's gravity without causing motion sickness or structural instability. We also have Earth's magnetic field to thank for protection. Its magnetic field protects us from harmful solar and cosmic radiation. In space, astronauts are exposed to dangerous radiation levels that increase cancer risks and damage DNA. On a year-long Mars mission, astronauts would be exposed to about 300 millisieverts of radiation, roughly 30 times the annual dose for a nuclear power plant worker. Solutions for these dangerous levels of radiation could include shielding habitats with Martian soil or even magnetic fields. But none of these options are currently scalable for a large colony to thrive long-term in space. Oxygen, water and food need to be produced or recycled indefinitely. The ISS relies on advanced filtration systems to recycle urine and sweat into drinking water. But even this system isn't 100% efficient. To be sustainable, a space colony would need to grow its own food using hydroponics or aeroponics. However, plants struggle in microgravity, and artificial lighting consumes huge amounts of energy. The first humans living in space would also likely experience psychological and social challenges. Isolation and confinement take an extreme toll on mental health. The longest continuous spaceflight was 437 days by Russian cosmonaut Valery Polyakov, but it left him physically weakened and psychologically strained. A long-term colony would require careful social engineering, including recreation, privacy, and conflict resolution systems. So, if we could solve those problems, what would a space colony actually look like? The spinning wheel design of Elysium is based on real scientific proposals like the O'Neill cylinder, a massive rotating space station designed to simulate Earth's gravity. O'Neill cylinders would be about 32 kilometers long and could house over 10 million people. Artificial sunlight, Earth-like agriculture, and self-sustaining ecosystems would be essential in recreating Earth's biosphere in space. In addition to the O'Neill cylinder, there are other potential ways to sustain life in space. A Stanford torus, a ring-shaped station that spins to create gravity similarly to an O'Neill cylinder. While Mars has some gravity, about 38% of Earth's, settlers on a Martian colony would need underground habitats to shield from radiation, and also lunar bases. The Moon is closer and has valuable resources like helium-3, but long nights would require significant energy storage systems. So how close are we to actually building something like Elysium? So far, the ISS has been continuously inhabited since the year 2000. But it's designed for short-term stays, not long-term colonization. NASA's Artemis program aims to establish a permanent lunar base by the 2030s, while SpaceX plans to send humans to Mars by 2040. But experts admit that building a self-sustaining Martian city could take up to 100 years. Despite these colossal plans, there's still technology that we need to develop. These include advanced radiation shielding, reliable artificial gravity systems, efficient life support, and food production systems. We also need to develop faster methods of space travel. Currently, one-way trips to Mars take 6 to 9 months, while a round trip could take around 3 years. Even if we figure out the technology, there's another question. Who gets to live there? In Elysium, only the wealthy elite lived on the station while the poor were left behind on a polluted and overcrowded Earth. The movie wasn't subtle about its message. Space habitation could easily become a tool of class division rather than a solution for humanity's survival. But is that outcome inevitable? We know that space travel is currently extremely expensive, prohibitively so. The cost of a SpaceX seat on a Starship mission to Mars could be in the range of hundreds of thousands to millions of dollars. The most expensive real-world ticket to space so far was on a Blue Origin flight in 2021. It sold for $28 million, which is far beyond anything your average person could afford. Prices would need to be far less expensive if we want to send people to space in large numbers. Would governments step in to make space colonization accessible to everyone? Or would it just become a playground for the ultra-wealthy? If colonization follows a corporate model, companies like SpaceX or Blue Origin could essentially own the colonies, charging settlers high fees for housing, food and oxygen. turning space into a privatized capitalist venture. Alternatively, if governments control it, they could enforce strict quotas based on skills, health, or even political alignment, creating a system where only certain types of people are chosen to represent humanity. In an extreme scenario, future settlers might have to sign multi-year work contracts or take on massive debt in exchange for a spot in space, essentially recreating indentured servitude in orbit. Could space colonization become a tool for power and control? If a single corporation or nation builds the first permanent space colony, they would have a powerful geopolitical advantage over Earth-based nations. A self-sustaining space colony with access to asteroid mining could control critical resources like platinum, gold, and rare earth metals, which are already in limited supply on Earth. A colony with advanced military technology could potentially establish a literal high ground in space, controlling global communications, navigation, and even weapon systems. For example, if the United States or China establishes the first colony, they could leverage their dominance to influence trade, military strategy, and political alliances on Earth. In a more dystopian scenario, a single company or private entity could create a monopoly over space travel, charging nations and individuals enormous fees to access the colony's resources or transportation systems. These concerns raise the real possibility that space colonization will widen global inequality. Right now, inequality on Earth is stark, and space habitation could make it even worse. In a doomsday scenario, it is extremely likely the wealthy would escape environmental collapse, while the poor are left behind to face climate disasters, food shortages, and political unrest. If the richest and most powerful individuals move off-planet, they might have little motivation to fix Earth's problems, effectively turning the planet into a dumping ground for those souls left behind. The wealthy might live in a high-tech colony with artificial gravity, clean air, and advanced healthcare, while the rest of humanity struggles to survive extreme weather, pollution, and dwindling resources. Another scenario of space division would be if a Mars colony could develop its own economy and political system separate from Earth, creating a future where Mars, settlers, and Earth's population become two distinct classes of humanity. In an extreme case, Mars settlers could even deny Earth-based people access to life-saving technology or resources produced in space. Throughout history, humans have used exploration and colonization to escape persecution or seek ideological freedom. Space colonization could offer a new frontier for these movements, but with complications. A colony founded on religious or political principles could impose strict cultural and social rules on its inhabitants. If multiple colonies with different political systems form, they could come into conflict, leading to interplanetary political tensions or even wars. A colony based on religious doctrine might impose laws on reproductive rights, gender roles, and scientific research, cutting itself off from more progressive Earth-based societies. That same politically radical colony might develop advanced technology, including weapons, and threaten Earth's governments and remaining inhabitants with it. Colonies could form economic or military alliances, effectively creating a new political order in space. So, if humanity's best and brightest leave for space, what happens to the people left behind? Brain drain could devastate Earth's economy and technological development. Environmental and social problems on Earth would likely spiral out of control without the proper resources and manpower of highly skilled individuals. In a worst-case scenario, Earth could become a forgotten backwater, viewed as a polluted relic of humanity's past. Imagine a scenario where Mars or a space colony becomes self-sufficient and no longer values a strong connection to Earth. It might cut off trade and communication with Earth, leaving Earth's population to fend for itself once more. Over time, Earth's population might shrink, its infrastructure might collapse, and human civilization on the planet could regress to a pre-industrial state. Conversely, space colonies could serve as a safety net, offering humanitarian aid and technological support to Earth, helping to stabilize the planet's population and environment. On the other hand, space colonization could be humanity's greatest achievement and the key to our survival. If space colonies become self-sustaining, they could support rapid population growth and provide a buffer against extinction-level events like asteroid impacts or supervolcanic eruptions. These advancements hinge on the ability to mine asteroids and extract water from the moon. Doing so could create a post-scarcity economy, where resources are abundant and our species no longer faces unnecessary adversity due to starvation or poverty. The dream of space habitation is closer than it's ever been, but massive challenges remain. We're still decades, maybe centuries, away from building a true space colony like Elysium. But every step we take, from lunar bases to Martian exploration, brings us closer to that future. The question isn't just can we live in space, it's should we? And if we do, how do we ensure it's a future for all of humanity, not just the privileged few? Let us know your thoughts in the comments. Is a future among the stars the next logical step for humanity? Or are we better off fixing Earth before we leave it behind? Don't forget to like and subscribe for more deep dives into the future of science and technology. Thank you for watching, and we'll see you next time.